Hey everyone, welcome back to another lesson in our tile game series. Today we're going to do some pretty big changes. We're going to be changing the way that we move. We're going to be moving to vector-based movement. So if we could take our lesson 8 folder and let's copy it and make lesson 9. For today's lesson, to keep it a reasonable length, we're actually going to turn off collisions because we're going to have to completely rework our collision detection. And that's going to be a separate lesson. So we're going to turn off collision detection and work on just moving freely like a spirit that can walk through walls. I'll rename this folder here to lesson 9. Well, let's go ahead and take a look at what we have right now and discuss what's happening and how it's going to change. I'll go ahead and open each one of these files. Because we will need probably all of them except for tile map, but I'll go ahead and open that for now. Okay, so currently we have what probably the most important feature of our game is that we're using a DT value, which stands for delta time, and that allows our game to be independent of frame rate. Right now, we're not rotating the image. If we wanted to make the game this way, we should make the man face in whichever direction he's about to start moving, which would be easy to do. But currently, we move, up, down, left, right, and that really doesn't allow us much freedom to angle our gun in a certain way. That's a good thing to have for certain games, but I think for us we don't want that. Also, it gives us a chance to talk about vectors, and we're going to be doing so in kind of a simple way because when we look at other games like platformers, vectors can be even more important, and so we need to learn a little bit of physics. So I'm going to open up just a little paint application here, and let me just take a little snapshot of this. So here's what we have right now. And the way I want to change this, okay, is I want to make it to where this player can rotate. It's not going to let me just do that. So we'll leave that there. Hold on. All right, so never mind. But I want to make it to where the player can rotate in some direction like that and then move in that direction. I rotate in that direction and move in that direction. And whichever way the player rotates, then the player can walk forward or backwards. So left and right keys are going to be an angle rotation, and forward and backward will be just walking forward or backward. And so in order to do that, we're going to be using what are called vectors. We'll just call it like a very simple we'll use simple vectors for position and for velocity. So a vector is a set of instructions. It's a set of instructions on how to move a point. So you can it's a mathematical concept, and you probably have heard that vectors contain both magnitude and direction, and that's really true. So if I have a vector, it has two-dimensional vectors would have two numbers. Three-dimensional vectors have three. So the vector 2, 3, sometimes written with parentheses, sometimes with these angle brackets, is a arrow. It's usually drawn as an arrow going from 0, 0 to 2, 3. And this vector has got two components, one called the x component, which here is 2, and the y component, which here is 3. They do have um, both magnitude and direction. The direction is actually this angle formed by this triangle, and the magnitude is how long this is. So we can describe the vector as this distance of this hypotenuse of the right triangle plus the angle that it's drawn at, or we can simply break it down to its x and y components. So we'll talk more about the math of vectors as we need to, but I think that's a good enough one to start with. So let's get right into it, and let's go to actually let's go to settings, get that out of the way. So for our settings, we have player speed, but now we need to have player rotation speed. And this will be in degrees per second. So we'll just leave it at 200 and I'll label it degrees per second. Okay, so let's go over our constructor for player. We have to call the super constructor in the sprite class. This will be just a quick review of the framework of our class. Player, after class player, we have pygame.sprite.sprite, which means that we're subclassing the sprite class from pygame. A call of super makes sure that we become a sprite. Without that call, we wouldn't be a sprite. So that makes us a sprite. We keep a reference to our game, so you can think of that as a way, a key that we can use to get back to main and access all of these things. We do it through our reference to main, which is called game. So we keep it as self.game. We have an image, self.image. We have our rectangle that we get from our image. Now, we're just going to go ahead and get rid of those. Okay? And we're going to use a vector for position and velocity. So self.velocity, that's going to be my velocity vector. And we can get a vector using the math module from Pygame. Pygame.math, and it is a class that we're calling the constructor of. And there's two vector classes. There's vector 2 or vector 3. We'll use vector 2 for this game. Two-dimensional vectors, and we just give it the x and the y values. And we're going to start with a velocity of 0, 0. So this is actually quite similar to what we had before. We had a vx and a vy. Now we're just basically storing it as just velocity. And self.position vector. And what's nice about the position vector is that all of our items that take tuples in Pygame also can take position vectors. And we're going to do something a little bit different with this, because remember that our game is a tile game, and our XY position is our coordinates in terms of tiles. So we're going to need to take our position vector. We have a velocity vector that starts at 0. And that velocity vector is telling us how to move in the game. Our position vector will tell us our positioning. But we need to talk about how we can scale vectors. So if I have a vector and I want to make that vector, let's say that vector is 3, 4. If I want to make that vector as big as on a tile, I simply have to multiply that vector x and y position by the tile size number. And I can do that in one at a time, but vectors multiplication by a scalar is defined that way. So it says that if I take a scalar like 7 and I multiply it to the vector 3 comma 4, mathematically that's defined to be 21 comma 28. You just multiply the x and y components by it. And so Pygame will take care of that for us. So I'm going to take my position and I'm going to make my vector out of it using the x and y values that we were given in the constructor's parameters. And then on the outside, I'll just simply multiply it by tile size. That's it. All right. We do need an angle. So self.angle equals 0. And we're going to keep a rotation speed. Actually, no, we don't need that rotation speed because we put it in our settings. So we'll just keep self.angle. That's all we need. And then we'll make sure we continue to add ourselves to our sprite group. So we'll leave that there. Let me add a comment to that, though, since we've added so many. Add to the sprite group from main.application. From the application class in our main. All right. So let's take a look at our check keys method now that handles our movement. It's going to be just a little bit different. We don't have this vx, vy anymore. We instead have self.velocity. But the velocity has an x component, and the velocity has a y component. So we just need to do it like that, which works perfectly. Self.vx and self.vel.y. So the velocity vector will have an x and a y component that we can access and set as 0 for the vx and 0 for the vy. I'm going to make a temporary variable called rotation. Let me think about that actually. Do I need a variable here? Yeah, I do. I need a variable here because I do need one more variable to keep track of how much the angle is changing. So I'm going to call this rotation amount. So I was right that I needed one earlier. Shouldn't have gotten rid of it, but it's not a speed, it's an amount. So we've got our angle that we're currently pointing at. We need to keep that, the angle. But then we need another variable for how much we're going to rotate. And since we have to calculate that, we need to go ahead and make a separate variable for that. Okay, and I could declare it here, but we'll declare it up here in our constructors so that it's easy to find. All right, if the player, let's see here, we're going to start by assuming that no keys are pressed, which means our velocities, x and y's, are 0. And we're going to assume that we're not rotating. So rotation amount will also be 0. So far, what I'm doing is basically making it back to the way it started, right? With every frame that we get the keys that are being pressed, we're going to make some assumptions. We're going to assume that we're not moving and that we're not rotating. And then based on what keys are being pressed, we'll change that. So that's this comment here pertains to these two settings here. We'll get the keys that are pressed if the key is up or the W. So the player wants to move up. Then what we're going to do is change their velocity to a new vector. And if they're moving up, I need it to be player speed, comma 0. But I need it to be in the direction that they are facing. So I'll say dot rotate self dot angle. So let me explain what that does. Let me clear all this out. So we are creating a new vector. Try that again. Don't want a red line there. Okay. So we're going to create a vector that is an x component of player speed because it's a velocity vector. So I'll just call it speed. And then I said the vector was speed, comma, 0. So that's our vector. I could make it 0 speed, but rotation is usually defined mathematically from the x-axis. So we're going to take that and we're going to rotate it like so, the amount of the angle. And so after we rotate it, it's still going to have the same length. Now it's going to have different x and y components. But those x and y components will be perfectly chosen so that this length is the same as when I made it here, but now with the angle that I'm desiring. And that's using the rotate method. Okay, if they are pressing the down arrow, we're going to move backwards. So our velocity will be kygame.math.vector2 negative player speed. And we're actually going to divide it by 2. We're going to divide it by 2. That way we walk, because you're walking backwards. You can't walk as fast, right? So that'll be a neat little nuance to the game. And again, we will rotate it something angle. So now what we're taking is a backwards vector. So it's going to be just like before, but the vector's negative magnitude makes us go backwards. If the left key is pressed, we're going to be changing our rotation amount by our rotation speed. And we need to do that kind of in 2 different steps here so that we can maintain frame independence, frame rate independence. I can't just change my rotation amount by my rotation speed. I need to include my dt, my delta time. So that's why. If we are rotating to the right, oh, you know what? I made a big goof here. Y'all don't put that. This needs to be minus equals. We're going to subtract from it our rotation amount. And this needs to be plus equals. There we go. So by using minus equals and plus equals, it just kind of makes it to where if they accidentally pressing both buttons at the same time, you just cancel each other out, as opposed to if I just set it to negative player rotation speed. I mean, if you press the left arrow key, self-rotation amount will be player rotation speed because it starts at 0. But we want to make it to where if they press the left and the right at the same time, which you often do when you're playing games, that they just cancel each other out. 1 minus, 1 plus. That's why. Okay, what's next? Well, we do not have to worry anymore about the diagonal problem. So we get to kill that. Isn't that kind of exciting? All right. And we'll do the frame rate independence. We'll do that in the update method. So we'll leave it just there. That's the check keys method. Okay? And that's it. Let's go to our update now. And we're going to go ahead and uncomment or comment the check for collisions for right now. Let's get rid of those. All right, so our update method, first thing we'll do is check the keys. Then we'll rotate our image and reassign our rectangle. So our angle is going to be plus equals by our rotation amount times our self.game.delta time. to make frame rate independence. Next, I'm going to mod equal by 360 so that if my angle is 370, it would just 370 mod 360 would be just 10. So it just kind of puts it back from 0 to 359. All right, we're going to change our image. And we need our player image. Now, our player image is in the main class self.playerImage when we loaded that, and that's why we're keeping a clean copy of that. So self.game.playerImage, that's our non-rotated version. Self.image is our working version. And we actually want to do it by negative of the angle, just from the way that angles are rotated. I can let you play with that and figure that out. And then we'll reassign our rectangle based on our new rotated image. Now let's play with our position vector. So position, in physics we learned that position is equal to velocity times time. Or more specifically, change in delta position is equal to velocity times the change in time. So that's what we're going to do. We're going to change our position. So I think POS was our position vector, yes? Yeah. So change our position. So we're adding two vectors here by self.velocity times our change in time, and that's what delta time is, delta t. Let me show how that works. So adding two vectors together, you just add their x and y components. Oh, got something weird here. Okay. So if I have two vectors like 3, 2, that's my position, and I'm going to add my velocity, and let's say it's 5, 6, then you just add their x and y components together. So our x velocity will be added to our x position, our y velocity will be added to that. But we'll be multiplying it by this delta t scalar, which gets multiplied to each one of those first. So pretty straightforward. All right. Now we need to actually move the position of the player on the screen, and that's handled with the rectangle. And we're going to do it one position at a time. So we'll change our position, our rect x to position.x. And at this time we would check for collisions. So I'm going to just leave that there as a reminder that that's what we're supposed to do. Then we'll move our y and check the y. And we'll probably have to redo that at some point. Okay. There we go. Okay, one last thing we're going to do, because we're going to be playing around with these vectors, is I want us to look at the rectangle that is being made using our player rotation. So I do want you seeing that. We're not going to fix the problem, but I want you to be able to see the problem. So let's go over to our main module, and in the application class, go down to, hold on, where is my outline? That always helps. There we go. I want to go to game draw. And if we're debugging, I want to see my rectangle. So we're going to say pygame dot draw dot rect. That's the command for making a rectangle. And what rectangle am I? What am I going to draw the rectangle to? To the screen. What color? We'll do white. And what rectangle? Well, we need it to actually be adjusted by our camera. So I'm going to say self.camera.apply. And I think that's fine. I'm curious if this works for if this will work for. Oh yeah, it should be fine. Because player has a rectangle, so that's fine. So we're going to apply the camera to our player. I just want to make sure that check our camera app and make camera method to make sure that we can handle that, and we can, of course. So that's good. And I want it to be that's the rectangle, and I want it to be drawn hollow. So I'm going to say width equals 1. If you don't include this in your draw rect, then what happens is it makes a filled in rectangle. So again, by review, to make a rectangle, pygame.draw.rect, tell it the screen, comma the color, comma the rectangle, and remember our camera returns a new rectangle that's positioned somewhere on the screen, and then the width. Okay, so that looks good. Let's run this code and see if we can't. All right, so you see how he's kind of bobby. Notice we can run through walls because we turned off collisions. Oh, my debugging didn't work. White is not defined. Oh no, I haven't made the color white. Let's go back and add that. Well, that's 255, 255, 255. All right, now it'll be happy. So run them again, and I'll press H for debugging. And I can see that. So you can see that as he rotates, the rectangle is actually changing. And that's going to be a problem. Also, the place where he's rotating is kind of an issue, which gives him that bobbing up and down. But we'll fix that in the next video. I probably also would like to make it to where we only draw the grid if we're debugging. So I'm going to change that as well in my game draw method. I'm going to just move this down here. So that's one last final change I'll do, so that when you run the game, I did not mean to put that there. I want it only if I'm debugging. There we go. There we go. Wrong indentation. All right, that looks better. So now the game runs with no grid unless I show it. Though I don't see my rectangle as well this time, but probably just need to move that down. Now, you know what? I'm just going to make it to where that's right here at the top. Because I still want it below everything. If self.debugging, then let's see if I like that. I didn't like the way it was looking. All right. Ah, that's better. Good. Forgot that the order that you draw it matters. Okay, so I can turn my tile grids on and off. And that's a good place to stop.